All right, here's number 12 from the practice for sine and cosine of a sum or difference. This is part A where they want the cosine of alpha minus beta. Now everyone's problem is a little different. They're randomly generated numbers here. So, but the idea is the same. That they give you some information about angle alpha, they give you some information about angle beta, and they want you to sorry, I didn't write the whole problem down. So they want you to find cosine of alpha minus beta, and then part B, I think it's beta, sine of beta minus alpha. But anyway, there's this to start with, and the identity is that the cosine of the difference of two angles is the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. Now, so there's some things that I know here. For instance, I know that the sine of alpha is 0.016. So this right here is 0.016. Right? I also know that the cosine of beta is 0.216. So this right here is 0.216 plus sign. What I need to do is I need to figure out what the sine of beta and the cosine of alpha are. Well, there's some triangles that I need to draw. That is, they think they tell me that both of these angles are in the first quadrant. Okay. Now these angles aren't necessarily related to each other. They're not in the same triangle or anything like that. This information right here tells me that, well, we're used to this being a fraction. We're used to this being like saying the sine of alpha is 3/5. And you'd say, okay, I'm going to make the opposite side. So if this is alpha right here, I'm going to make the opposite side 3 and the hypotenuse 5. Well, I don't have it as a fraction, I have it as a decimal. But I can always think of it as a fraction because I can always say, well, just divide by 1. So I'm thinking of the opposite side as being 0.016, and the hypotenuse is 1. Likewise, for this one right here, now the angle is beta, and they're telling me that the cosine is 0.216. Again, I think of cosine as adjacent over hypotenuse. So again, thinking of this as divided by 1, so make it 0.216 here on the adjacent side, and a 1 right there. Now I can use Pythagoras to get that other side for both of these things. So over here, this side is the square root of 1 squared minus 0.016 squared. And if I break out my calculator, I got 1 minus 0.016 squared, and the square root of that. I get, goodness, 0.99987. All right, I'm not gonna round it if I can too much, if I can avoid it until the end. Likewise over here, this is the square root of 1 squared minus 0.216 squared. And a quick calculation of that, I got 1 minus 0.2 squared gives me 0.85. Whoops. Try this again. 0.885324. So anyway, the cosine of alpha now is this number, 0.99987, and the sine of beta is this divided by 1, so it's that 0.885324. And so, so now I can multiply these things together, right, and add. So this information tells me about a triangle with alpha in it as an angle, giving me the opposite side with a hypotenuse of 1. Okay. Anyway, and so what do I get here? I got 0.99987 times 0.216 plus 0.016 times 0.885324. Anyway, So it looks to me like this answer is 0.2301. I think they wanted 4 decimal places. So there we go, 0.2301. And then they also asked for what's the sine of, and I be careful, I think they do ask for beta minus alpha here. And so this would be the sine of beta. Actually, I'm going to do a quick check. Is that what they asked for? Yes, sine of beta minus alpha. So sine of beta cosine alpha plus, no, not plus, minus cosine beta sine alpha. And we have all these things now because we know the sine of beta is the 0.885, the cosine of alpha is the 0.9987, the cosine of beta is the 0.26, and the sine of alpha is the 0.016. So you know all those numbers are there, and you can calculate them just like this. If they tell you one trig function of an angle, you should be able to find all of them. Right? Now, one more thing about this. I do this generally geometrically. I draw the picture. But still, you could do it algebraically in that if you realize that there's an identity that the sine squared theta plus cosine squared theta equals 1, and you can say, well, if I know the sine, can I figure out the cosine? Yes, the cosine of theta would be the square root of 1. Well, it's plus or minus the square root of 1 minus the sine squared of theta. And the plus or minus is your choice as to which quadrant you're in. Since they told me I'm in the first quadrant here, I want the plus. I want the plus there. But notice, this identity here is saying that the cosine is the square root of 1 minus the sine squared of theta. I mean, what calculation did I do over here? I did 1 squared minus the sine that they gave me, the sine squared of theta. So, I mean, that's the calculation I did, but I thought of it geometrically. Some of you may be more inclined to think algebraically, using this identity. If they tell you either sine or cosine, you can solve for the other one, right? So, I'm happy with you doing it either way, whatever way you see better. There you go. There's number 12. 13 is very much like it. 14 is very similar too, right? They give you those trig functions in decimal form. So think of them as a side length with 1 as a hypotenuse. There you go.